What's up, y'all? Hey, we got your test tomorrow, Thursday. Wait, Thursday. Thursday, not tomorrow, Thursday. So, hey, yo, man, y'all use this video. Prepare for the test, man. Remember, all right, I got the challenge. Get a 100. All right, bring me your test paper, and I got something for you. All right, regardless of who class you have, man, all right, or what period you're in, bring me your test. I got something for you. Also, man, hey, if you like the video, thumbs up. And subscribe so you can get all the notifications when I upload a video. All right? Cool. Let's go ahead and get started, all right? All right, guys, this first example right here. This first example, we have what are the 4 different ways to represent a function? All right, so we've talked about several different ways, or 4. All right, and they are a graph. All right. An equation. All right, we have a table. All right, and lastly, we have a verbal description. All right. All right, verbal description. Okay. All right. So now let's go and look at number 2. Number 2 says state the type of regression you should use. All right, for the following. All right. Take these first 2 y values right here. All right, and subtract 75 minus 60. All right, that'll give you 15. And 80 minus 75 is 5. 75 minus 80 is going to be negative 5. All right, 75 minus 80 is negative 5. 60 minus 75 is negative 15. And 35 minus 65, 35 minus 60 is a negative 25. Okay. So now we take it a step further. What's the difference between 5 minus 15? Negative 10. What's the difference between negative 5 minus 5? Negative 10. Negative 15 minus, all right, minus negative 5 becomes plus 5. So negative 15 plus 5, negative 10. Negative 25 minus 15, which again becomes plus 15, is negative 10. All right. So this is the first difference. This is the second difference. So because it's the second difference, guys, that makes this quadratic. All right. So the type of regression, this is a quadratic regression. Okay. Now over here for number 3, man, guys, look, I just want you to be able to look at it and kind of tell. You guys notice how this increases 25, 62.5, 156.25, 390.63, 976.56. That is such a significant increase right there. I can almost bank on it being exponential. All right, look at the increase, guys. And if you were to plot these in, your R squared is going to be 1. All right, into your table. So this is exponential regression, okay? Let's go and look at number 4. Number 4 says Matt started a savings account with 500. Guys, he invested his money into an interest earning account. The table shows the value of the account. Write an appropriate function for X years. It says use the function to predict when the account will reach $1,000. All right, so first we need to figure out what type of equation this is. All right, so if we take this information, all right, and we put it into our calculator, we'll stat, edit, all right, and then we have list 1 is 1 through 4. So I'm going to delete these here. And over here, you plug it in your y values, which are $540, $583.20, $629, and 86 cents. And lastly, $680 and 24 cents. All right. So I put those in. All right, then I go stat and edit. Well, we also know looking at that right there, not stat edit, I'm sorry. I went back to it, but we know that that's not first difference, all right? That's not consistent, okay? So let's check the other ones, all right? And you guys remember we look at our R squared, our diagnostic, all right? Oops, wrong thing. Let's check it again. All right, so I'm gonna go quadratic regression, option 5. All right, let's see what we get for R squared. All right, this one gave us 0.99, 1, 2, 3, 4, 5, 6. So 6 nines. All right. Well, let's see if we can get closer. All right, let's try cubic regression. All right. Oh, that's 1. All right, so that tells us that this is our equation. All right, R squared is 1. That's our equation. All right. Let's say hypothetical, you looked at it and you said, you know, it's exponential. All right, exponential. Exponential is option 0. All right, and you did it that way. The problem with exponential is this. You see that? That's a bunch of nines. It is 3, 6, 7, 8, 8 nines. But all right, it's not as close to that 1, that R squared, which is cubic. So stat, edit, calculate. It was cubic 6. All right, so there's our equation right here, okay? So we're gonna add that, guys, to our table over here. Not our table, but our equation. We write that down. So we have 0.04x, excuse me. It was 0.04x cubed plus 147x squared plus 38.49x plus 500. All right, there's our equation. Okay, there's our equation. Now, the question says, how long will it take to reach 1,000? Well, let's go back to our calculator, okay? Here's our equation. We're going to plug that equation into the y equals tab. So if I go right here, let me do this real quick, and put this equation right here into the y equals. All right, that's going to give us, all right, so I put it in the calculator like this. All right, now I'm going to hit graph. All right, let the calculator graph or sketch whatever it's going to sketch. Now I'm going to go to the table, second graph. Here's your table. All right, and the question told us, all right, when will this thing reach $1,000? So we're looking at, you see 9 years right here is about 994.64. All right, 10 years is a little over 1,000. So I'm going to say somewhere between 9 and 10. All right, so roughly 10 years. We'll say 10 years, all right, just to keep it safe. About 10 years, all right. Okay, so about 10 years. All right, let's look at this next example here, man. It says for the function, all right, A, graph the equation. B, tell whether the graph opens up or down. Identify the vertex. State the transformations to the parent function. State the intercepts, list the zeros, and state the intervals of increase or decrease, okay? So this first one right here, all right, first of all, this negative right here, see this negative, guys? That tells me that I need to be going down. All right, this negative says my triangle is going to open down like that, okay? Well, not triangle, my V is going to open down like that, all right? So I got to find my vertex. Well, finding my vertex, guys, I don't know if you remember, but your vertex is H and K, all right? So if you look at H right here, all right, what is H? You do the opposite of what's right here. This is -4. All right, this is -4, so H is 4. All right, right here, K is 3. You take this as face value. You do not change the sign of that. All right, so it's +3. So this is my vertex. All right, so we go over to the right 4, go up 3. Here's my vertex. All right, now know this thing opens down. All right, but I got to find one more thing. I got to find my rise over run. All right, rise over run. Okay, and now finding the rise over run, look at A. All right, right here, there's an A value, guys. All right, there's an invisible 1 right in between the negative and that bar. All right, so 1 is the same thing as 1 over 1. All right, so my rise is 1. All right, and my run is 1. So I go down 1 over 1, down 1 over 1, down 1 over 1, and continue this pattern. All right, until I sketch my graph. All right, same thing this way. Down 1 over 1. Ooh, yeah. Down 1 over 1, down 1 over 1. All right, and so on. All right, until I just keep going. So anyway, I'm going to use this tool, this line tool, to sketch this graph. All right, so we have one going this way and the other side going this way. All right, I'm just going to extend it as far as I can go, okay? So now the questions, guys, let's answer these questions down below. The first one says, does it open up or down? Remember that negative says down. All right, so of course it's down. All right, the vertex, we found that using the H and K method. It's 4 and 3. Now transformations. All right, remember, the negative says reflect the Y. Reflect the X. So we have reflect the X, X-axis. All right. This negative 4 right here says right 4. All right, and then the plus 3 says up 3. All right, up 3. Okay, those are your transformations. Now, intercepts. Are there any intercepts that we can see? Yep, we can see these intercepts. Here's one intercept right there, and that's going to be x is 1, 0. All right, and this one, we have x is 7, 0. All right, so those are my x intercepts. We also can see the y intercept right here. Let me change colors. Here's the y intercept. All right, right here. All right, and that point is 0, -1. All right, so we can see all our intercepts right here. That's pretty cool. 1, 0, 7, 0, 0, -1. And 0, 7, 1. 0, 1, right? This is your y-intercept. Those are your x-intercepts. Which brings me to the zeros. Guys, your x-intercepts are the exact same thing as your zeros. So some of you guys may write it as points still. All right, some of your teachers may have you write it as x equals 1 and 7. All right, these are the same thing. Doesn't matter, however your teacher tells you to write it. Now we have to find the intervals of increase and decrease. All right, intervals of increase and decrease. So let's look at this. Okay, let me clear this off so I can explain it. All right. We first look at the x value of the vertex. We said it's 4. All right. Now, what's way out here to the left, guys? That's negative infinity. What's way out here to the right? That's positive infinity. All right. Now, all you need to know are those three things. The h value for the vertex. All right, negative infinity and positive infinity. So here's how you read this. You read a graph from left to right. All right. So as I go to the vertex, all right, how am I traveling up this line? I'm going up. All right, from left to right. I'm going up the vertex. This is an increase. All right, so there's your increase. And then as I leave the vertex, I'm going down. All right, that's a decrease. So this is our decrease. Well, there's your intervals right there. From negative infinity to 4 is an increase. From 4 to positive infinity is a decrease. All right, so here we go. Increase, we said was negative infinity to 4. All right, and decrease is going to be 4 to negative infinity. All right. Let's get started over here. Let me clear some of this off. All right. Again, let's find, first of all, we address, does this open up or down? There's no negative out front, so this clearly opens up. All right, so I'm going to go down here and answer that question. That's an up. All right, now the vertex. I got to find the vertex. Well, look right here again, H and K. What's H? 6, so you're going to put the opposite, -6. And what's K? There's no K out here, so you put 0. All right, -6, 0 is my vertex. All right, -6, 0. Now, we have to find, or we need to graph it. So if I graph my vertex, negative 6, 0, negative 6, 0, all right, and then I look at my A value. A right here, guys, is 2. All right, so we got to find our rise over run. So if I take 2, well, 2 is the same thing as 2 over 1. So there's my slope, 2 over 1. All right, we know it opens up because there's no negative, so I go up 2 over 1, up 2 over 1. All right, rise to run is 1, rise to run is 1, rise to run is 1. And you do it the opposite direction as well. Rise 2 over 1, rise to run, rise to run 1, rise to run 1. All right, so now I use my tool to sketch my graph. All right, there's my V, okay? Now, let's answer a couple more questions. Transformation. This 2, since the A is larger than 1, guys, when A is larger than 1, you have what's called a vertical stretch. All right, so I have a vertical stretch by 2. All right, and that negative 6, that positive 6 says, right 6. Left 6, sorry, left 6. All right, do the opposite, so left 6 says. All right, now my intercepts, guys. Our intercepts, well, we can see this first one, right? We have one x-intercept, all right? So we have negative 6, 0, all right? Next, we need to find this y-intercept. This is the only x-intercept that's going up from there. All right, for our y-intercept, a couple different ways, guys. You can just think about it. I got to go up 2, which is 12, and over 1. All right, so that would be 12, 0. Or I'm sorry, I wrote that wrong. It would be 0, 12, because I went up 12. There's your intercept right there, okay? Your y-intercept. So x-intercept, negative 6, 0. And y-intercept, 12, sorry. I don't know why I keep wanting to do that. 0, 12, all right? Boom. Now, zeros. Zeros are the exact same thing as x-intercepts. So negative 6, 0. All right, or x equals negative 6, however you write it, okay? Now, intervals of increase and decrease. All right. Well, let's look at this. What's way out here to the left is negative infinity. What's way out here to the right is positive infinity. And what is the x value right here? Negative 6. Now, trace your line from left to right. Remember, you go from left to right. Trace the line. How do I get to the vertex? I go down, all right? So that means this side is a decrease. And from here, as I leave the vertex, I'm going up, all right? That is going to be an increase. So there are my intervals, okay? Negative 6. Negative infinity is 6. Negative 6 is a decrease. Negative 6 to positive infinity is the increase. So increase, negative 6 to positive infinity, and decrease, negative infinity to negative 6, okay? All right. Okay, now let's go back over here and have another look. For this one there, oh, the light's cut off. Let's see. All right. Gotta wave your hands, get the lights to come back on. So this last problem right here. Yep, let's start by addressing this negative. The negative tells me my V is gonna open down. All right. Now for the vertex. H, do the opposite, is 1. K is plus 4. Don't change the sign here. It's just 4. That's my vertex, 1 to 4, or 1 and 4. So I go over 1, go up 4. Here's my vertex. Now I know I'm going down. Now I got to address my slope. Rise over run. Well, look at the A value. All right, A is 1/2. All right, A is 1/2. So that gives me my rise over run. So now I just plot my rise over run. Now remember, this is going down. So I'm going to go down 1 over 2. All right, my rise is 1. Down 1 to the right 2. Down 1 over 2. Down 1 over 2. All right, down 1 over 2. Well, that's it for that. Over here, down 1 over 2. Down 1 over 2.
Israel, you're right.
Down 1 over 2. Down 1 over 2. All right, down 1 over 2. Okay. So anyway, let's sketch that. And right there. Let me move this up. Okay. Now, I have my sketch. Let's go and address the rest. All right. Remember, the negative right here says this thing opens down. All right. The vertex we said was 1, 4. Transformation reflects x-axis. Again, and it reflects the x-axis because of the negative out front. The same reason it opens down. Now, 1/2. 1/2 is less than 1. A is less than 1. Since A is less than 1, you have what's called a vertical compression or shrink. All right, you can write compression here or you can write shrink. All right, it's the same thing. All right, by 1/2, you write compression or shrink, okay? Now, the -1 said go right 1, and the 4 said up by 4, okay? Up by 4. See the -1, right 1, up 4, okay? Now the last thing, intercepts. Let's look at our intercepts, all right? Where our y-intercept, we got to find our y-intercept. So I'll solve that in a second. X-intercepts, though, we can see those. All right, we can clearly see those. This one right here is going to be -6, -7. So -7, 0, and 7, 0. All right, 7, 0. Actually, you know what? I realized I made a mistake. Let me show you the mistake I made. All right, I will edit it out, but I want to actually show you the mistake I made. Right here, down 1 over 2, I got my points in the wrong place. It should be there, down 1 over 2, there, down 1 over 2, and there. All right, so some of my points are in the wrong place, therefore my graph looks wrong. All right, I just realized that. So make sure that's a note to yourself, man. When you're taking the test tomorrow, make sure you make sure you check yourself and make sure your points are right. All right. So now let's look at the x-intercept. That should be -8, -9. So you have 9, 0. All right. Those are the x-intercepts. Okay. Let me check down 1 over 2. Boom. Okay, cool. Now for this y-intercept, we got to find that. All right. -7, 0. And 9, 0. All right. Now for the y-intercept, let me go down here where there's some white space to address that. Remember with the y-intercept, what you have to do is make x 0. All right. So here's the equation. All right. So you take the equation, 1/2, -1/2, excuse me, times the absolute value of x minus 1 plus 4. Well, to find the y-intercept, you make x 0. All right, make x 0. So we know that x is going to be 0, so I do that. I make that 0. All right, that's now 0. So 0 minus 1 is -1. All right. Now, what's the absolute value of -1? Well, the absolute value of -1 is 1. So I have -1/2 times that 1 plus 4. Now, what is -1/2 times 1? -0.5. All right, plus 4. And -0.5 plus 4 is going to be 3.5. All right, or if you were to convert that to a fraction, let's go back and say we did a fraction. And went -1/2 times 1 is -1/2 plus 4, right? Well, if I made it into a fraction, -1/2 plus 8 over 2, I'll get 7 over 2. All right, 7 over 2. All right. So anyway, the zeros are the same as the x-intercepts, -7, 0, and 9, 0. All right. Then to intervals of increase and decrease. All right. Again, what's way out here to the left? Negative infinity. What's way out here to the right? Positive infinity. What's smack dab in the middle of this thing is 1. As I trace this line, all right, going up. All right, I trace this line, I go down. So from negative infinity to 1 is my decrease. I'm sorry. That's my increase. And from 1 to positive infinity is my decrease. All right. So there's your interval, okay? All right. Let's see. Should I make another video? No, let's keep going, man. Let's keep going. It's not much more. All right. Piecewise functions, guys. That's what we've been working on the last 2 days. All right, so let's go ahead and dig right in. Evaluate the following piecewise functions for these right here. All right, these x values. -2, 6, and 4. All right. So for the first one, all right, -2, f of -2. All right, which condition does -2 fit in? Is -2 less than or equal to 0, or is -2 greater than 0? It's this one. -2 is less than or equal to 0. So I plug in -2 right here. You have you plug it in right here. So -2 times 2 is -4. All right. Now I take the value 6. F of 6. All right, and let's evaluate that. Is 6 less than 0? Nope. Is 6 greater than 0? Yes. So we plug in 6 right here. 6 minus 2 is going to give me 4. Then we evaluate the last x value of 4. All right. Which condition does 4 fall in? Is 4 less than 0? No. Is 4 greater than 0? Absolutely. All right, so you have 4 minus 2, 2. Okay. For this one, all right, we have -2. All right, which condition does -2 fall in? Is -2 less than or equal to 1? Is -2 between 1 and 2? Is -2 between 2 and 4? Is -2 greater than 4? All right, and -2 is less than 1. All right, so if I plug in -2 here, all right, and then -2 squared is 4, so I have -2 minus 4, that gives me -6. All right, now we address f of 6. All right, 6 is greater than 4, so you have 6 right here, so you get -6 minus 8 is -14. And next we have f of 4. All right, 4 is also greater than or equal to 4. All right, greater than or equal to 4, so we have -4 minus 8, that's -12. Okay. Lastly, we have f of -2 for this one. All right, -2 is less than or equal to 1. All right, so we use this one. We go -2 right here, so -2 minus 1 is going to give me -3. -3 squared is 9. All right. Then we have 6, f of 6. All right, if I take 6, 6 is larger than 1, so 6 plus 1 is 7. And then you have 4. All right, f of 4. Well, 4 is larger than 1, so you have 4 plus 1, 5. All right, 5. All righty, let's go ahead and keep going. Right here, these are step functions. Graph the piecewise function. Here we're looking at step functions. All right, our first function is 4. All right, so at 4, we have 4 from -3, closed circle because of the equal sign right there. And over 4, we have an open circle because it lacks the equal sign. There's no equal sign, so it's an open circle. At -1, right here, at 4, we have a closed circle because of the equal sign, and at 6, we have an open circle because it does not have the equal sign. And right here at 6, you have a closed circle at 6 and a open circle at 10. So there you go right there, okay? Right here, we've got to graph this piecewise function. All right, then, graph this absolute value and then write a piecewise function. So here we go. Graphing it, this tells me it opens down. All right, this tells me that the h is -1 and the k is -3. So that's my vertex, -1, -3. Now, I know this opens down because of the negative, and my rise is going to be 2, and my run is 1. So down 2, 1, 2, ooh, didn't mean to do that. Down 2 over 1, that's my slope. Down 2 over 1, down 2 over 1, all right? Down 2 over 1, down 2 over 1, down 2 over 1. All right, so there is my v for absolute value, okay? Now, I got to make my piecewise function. Well, this one right here, well, let's first address this, okay? This right here, the x value is -1, all right? So if we were to go this way, we're going to say the x's are greater than -1. If we go this way, we say that x's are less than -1, all right? Now, we got to make our equations, okay? Remember, if you looked at my last video, all right, which hopefully you did, you got to have one negative. All right, this is the negative, and you got to have a positive. So let's address the negative first. Distribute the -2, you get -2x minus 2. All right, let me rewrite that. -2x minus 2 minus 3. All right, then -2 minus 3 is -5. Here's one equation. Over here, you have 2x plus 2 minus 3 simplifies to 2x minus 1. All right, now you got to look, guys. All right, right here at your graph and look at your y-intercept. Well, right here, this y-intercept is -5. Which one has the -5? That would be this one, okay? This equation goes to this side, all right? So with this condition, the equation is -2x minus 5 because the y-intercept is right there, all right? Which means this equation goes over here. So when I write this piecewise out, guys, all right, you're going to have 2x minus 1 for x is less than -1, and -2x minus 5 for x is greater than -1. Now, which one gets the equal sign? Guys, you know what? Honestly, it doesn't matter. All right. All we need to do is account for the -1. So you can put the equal sign on either one. All right. Just do the first one. You know, that way you don't forget it. All right. Doesn't matter. Okay. There's your piecewise function. Now let's take a look at this right here, this next one. We got to evaluate for f of -2. All right, so let me zoom out here so we can have a little bit more space. F of -2. Well, if I look at my graph, all right, 1, 2, I'm sorry, x is -2. So if I go 1, 2, -2, what is my y value? All right, that right there is 1, 2. So 2. All right, there's the y value on the function. If I look at x is 0, what's the function? Right there. All right, that, guys, is -1. All right, we're on the home stretch. All right, is 4, -5 a solution of this piecewise function? Well, think about it, okay? First of all, the x value is 4. So you have to ask yourself, is 4 less than 4? No, so we don't look at this one. So now we go, is 4 greater than or equal to 4? It is. All right, it is. So we're going to look at this equation right here, -2x. So if I take -2 and plug in 4 for x, all right, because it's -2x, that right there is going to give me -8. All right, that does not give me -5. So the answer is no. All right, the answer is no. What is the vertex of the following equation? Does it open up or down? Well, first question, does it open up or down? That negative says down. For the vertex, look at the h. All right, do the opposite, -9. All right, and then take that as face value. All right, it's -5. All right, that's my vertex. All right. Okay. Answer the questions below. Again, does it open up or down? That tells me down. What's my vertex? Do the opposite here, -2. All right, up 3. Transformations. The negative says reflect x-axis. All right. That +2 says left 2. And that 3 says down 3. Okay, down 3. Now, we got to address the intercepts, okay? For your intercepts, guys, remember, for your x-intercept, let me make a new page here. For your x-intercept, your x, or excuse me, your y is 0. All right, so if I take that equation, all right, and the equation is negative x plus 2 plus 3, all right, and I make x, or I make y 0. All right, I will solve this, okay? So now when I solve this, I'm going to go and subtract 3 on both sides. All right, so -3 here, -3 here. So 0 minus 3 is -3. All right, and then I'm going to get rid of this negative right here. All right, by multiplying by a negative on both sides. So we're dividing by a negative. So divide by -1. Divide by -1. All right, that cancels. And so does the negative here. So I have 3 equals x plus 2. All right. Now, you have to remember with the absolute value that you have 2 values. All right. You got to have a positive and a negative. So since you have 3 equals x plus 2, you're also going to have -3 equals x plus 2. Okay. So now, just solve it. Subtract 2 over here. So 3 minus 2 is 1. All right, that's your first x-intercept. 1, 0. And then you do this one over here. Subtract 2 on both sides. And you're going to get -5. All right, this is your other x-intercept. -5, 0. All right. All right, so these are our x-intercepts. So let me go back. 1, 0, 5, -5, 0. All right, and since those are the x-intercepts, they're also the zeros. All right, now we just got to find our y-intercept, okay? So let me go back over here. To find my y-intercept, guys, all I've got to do is make the x value 0. All right, make the x value 0, like so. So again, for your y-intercept, your x is 0. All right, so you have y equals -x plus 2 plus 3. All right, make this 0. Well, 0 plus 2 is 2. And the absolute value of 2 is 2. And negative times 2 is -2. And -2 plus 3 equals, oops, sorry, I got an equal sign. 1. All right, there's your y-intercept. So 0, 1 is your y-intercept. So let's go back. Here we go. All right, there's your y-intercept. Now, increase and decrease. All right. If you imagine this, okay, if you did a quick sketch, all right, wait, This is the graph. Oh my gosh, did I just do this whole thing by hand? I did. This is the graph. 1, 0, -5, 0, and 0, 1. Guys, I can't believe I just did that. All right. Well, in behavior, man, you have negative infinity. The x value here is going to be 1, 2, -2, and positive infinity, right? So this right here is your increase. I increase to the vertex. All right. So you have from negative infinity to -2. And right here will be decrease. All right. From -2 to positive infinity. All right. Wow. I can't believe I just did that, man. I did all that by hand. The graph's right there. Look at that. Well, that's good, man. This is something good to know. All right. Now, let's look at this right here. It says Sarah went on a 7-hour hike up Blue Ridge Mountain. In the first 2 hours, she traveled 20 miles. She paused for about an hour to take a water break and rest. Then in the next 2 hours, she traveled another 30 miles. Again, after pausing for 30 minutes, she finished his last, it should be her last 30 miles because it's Sarah, so that should be her. Unless it's a guy named Sarah, no judgment there. But draw a graphical representation of this, all right? So let's look at this. All right, and this is actually, man, I think straightforward, all right? So let's take a look at our graph. This thing says they climb 20 meters for the first 2 hours, right? And then rest for an hour. All right. So look, let me first of all say this. This is miles. This is time. All right. Or hours. Okay. So for 2 hours, you climb 20 meters, right? And then you chose to rest for 2 hours. So for an hour. So you see how it's straight right here from 2 to 3. That's you resting. All right. Or Sarah resting. All right. Then climbed again. Let me see. She paused for an hour to take a water break. Then the next 2 hours, she traveled another 30 miles. All right, so 20 plus 30 miles is going to give me 50. All right, so I got to go up here to 50. All right, and she traveled for how long did she travel? For the next 2 hours. So from 3, 4, 5. All right, she traveled for 2 hours. So we go right here. Right? Oh, that's not a straight line at all. Let me see if I can get this a little straighter. All right, a little better. All right. And then she rests for 30 minutes, so half an hour. So about right here. All right. Ooh, too far. Use another color. She rests until about right here. Right? And then finish the last 30 miles. All right, so 30 more miles. All right. Would be up to 80 miles, right? For 80 miles. Now, here's one thing I want to point out. It's a 7-hour hike, right? 7-hour hike. Ooh, man, didn't mean to do it. Whoa, what's going on, pencil? All right, my pencil went on the fritz right there, guys. Sorry about that. I don't know what happened. But it's a 7-hour trip. Right here's 2 hours. All right, 30 minutes. Right here is 2 hours. I'm sorry, that's another hour. So 1 hour, 2 hours. All right, 2 more hours. 2 hours, 3 hours. All right, 2 more hours, going to be 5 hours, 30 minutes. So how much time is remaining? Just an hour and 30 minutes. All right, an hour and 30 minutes. So we're at 5 hours and 30 minutes right now. All right, we'll go over 1 more hour and 30 minutes. That is where we will conclude our journey right here. All right. 7 hours. 7 hours, right? Because we only hike for 7 hours, okay? Man, this is your graphical representation. I know it's not great, man. I can't draw a great line, but guys, that's it, man. This will conclude. Hey, good luck on your test on Thursday. I hope this helps. I wish you the very best. And again, if you make that 100, all right, come see me. I got something for you. All right, bring your test. Bring it to me. All right, also, if you like the video, give me a thumbs up and subscribe, okay? I'll start Unit 10 videos coming up soon. All right, have a great evening or morning or whenever you're looking at this video. Talk to you later.